Welcome to the Integrated Design Project presentation for Group C. Introduction. The product that the group is designing is a smart agriculture sensor. Using the mote sensor XM1000 as a base, the product is modified to be able to detect light density, humidity, and temperature from its surrounding environment. Additionally, the product has been modified to run on electrical energy converted from solar energy and 2AA battery as an alternate source of energy to further combat climate change. The product makes use of a mini silicon solar cell to convert solar energy and generate electricity. The product is expected to function in any climate. The product is a local area network-oriented IoT-enabled device. The group has also designed an external case to protect the product from outside interferences. After much consideration, the group decided to make rectangular holes to allow ventilation in order to prevent overheating of the device. The flaps were deployed to prevent rainwater and dust from getting into the external case. The materials used for designing the external case was assumed to be zinc since it is durable and recyclable. Problem statement. Production risk has also always been a huge factor in the industry of agriculture. Production risks are always affected by various factors such as environment, pests, mishandling of workers, inaccurate predictions for seasonal plantations, and so on. Over 50% of farmers face such issue and are helpless against this kind of problem. Without crop produce, the farmers risk losing money and eventually going into debt. Most uninformed or less educated farmers are unable to make up for the gross profit and return on investment upon the failure of harvesting their crops. It has become clear that traditional methods of farming are unreliable and modernized method of farming needs to be introduced into the agriculture industry. Methodology. The product is first placed at a desired location by the user. The location can be an open field, underground, or inside a room. It is then allowed 1 minute time to adjust the surrounding environment. The product detects light density, temperature, and humidity of the surrounding area. The product then transmits the parameters it detected to the user. The user can set a limit threshold specifically for light density and temperature. Upon reaching or exceeding the set threshold for light and temperature, an alarm goes off. The alarm goes off in the form of a text notification to the user's IoT-enabled device, for example, mobile phones. The alarm can be fixed according to the user. For example, the alarm goes on for 30 minutes, it can be stopped or interrupted by the user. It can only notify the user once, and so on. Methodology continued. The primary energy that the product uses is solar energy and the secondary energy is electrical energy. The product makes use of solar energy gathered during the day and convert it to electricity. The excess solar energy are used to recharge the 2AA batteries through the 4 jumper wires coiled around the battery supply. In the case where the device does not have enough energy to sustain the running functions of the product, the device will use the backup substitute electrical energy. Once both energy sources have been depleted, the product will shut down, and it is recommended that the user replace the batteries or simply place the product under the sun for a few hours for the batteries to recharge. View of quantities. The group used XM1000, a mini silicon solar cell, 4 jumper wires, and 1 external case, items costing 126 ringgit in total. The external case which is used in this project is 3D printed and thus incurred no loss. The 3D printer is provided with respect and courtesy by Curtin University. Product demo. Before we go into the demo, you need to know the components of the XM1000. It consists of the user and reset buttons, which are the white and red buttons. The SHT11, which is responsible for detecting humidity and temperature. The Hamamatsu, which detects light density, and the red and blue LEDs. This slide shows a simulation of the mote sensors in the field. Users can use this software called Kuja to determine the number of sensors needed for their field through this simulation. This allows users to accurately determine the amount of the product needed to cover the entire field. As you can see, it returns temperature in degrees Celsius and humidity parameters. The group has used Instant Contiki 2.7, a virtual machine, as the base platform for programming. The program is uploaded and run in Terminal, which is another software similar to Command Prompt. The terminal can recognize any syntax errors in the code and can notify users which error line of the code. The program is coded in C language. Here you can see that the code is running and starting the process. In this slide, as you can see, it returns the light density to the user as 144. I have also programmed it to return my name upon completion. In this slide, it returns the temperature parameter, temperature in degrees Celsius, and percentage relative humidity. In this slide, I have preset the temperature threshold to be 25.5 degrees Celsius. Thus, it returns an alarm as the temperature is 26 degrees Celsius and has exceeded the threshold. It will keep returning an alarm until it is interrupted or stopped by the user. The LEDs of the XM1000 will also blink rapidly. For this slide, my device has been recognized and connected to the product, and thus it sends me the notifications for parameters and the alarms separately. Limitations: insufficient manpower or personnel, insufficient resources due to the COVID-19 outbreak. The COVID-19 outbreak has driven up prices of the products from the market, and many couriers are unable to deliver due to country lockdown. No ideal tools or devices to work with due to the movement restrict order enforced by the Malaysian government. Country lockdown, thus unable to purchase hardware from foreign country and is forced to work with hardware available at hand. Price limit of 150 ringgit. Limited ideas due to the COVID-19 outbreak. So, any questions? feel free to contact this email if you have any inquiries regarding to this project or simply comment below. Thank you.